Impossible and sure events. The empty set phi is called the impossible set, and set S, which is basically a sample space, is called sure event. Simple event. If the event set E has only one sample space, then it's called simple or elementary event. Now let's consider an example. So the probability of getting two heads is basically E is equal to H in H. It simply means that if we toss a coin twice, the probability of getting head out of all the tosses will be, we have one case when both the two outcomes are head and head. So we can say that probability of E is equal to 1 over 4 because out of 4 sample spaces, we have only one event. So the probability of E will be 1 over 4. Compound event. If the event set E has more than one sample space, then it's called compound event. Now let's consider an example. So the example is, let E is equal to exactly one head and F is equal to at least one head. So when we say exactly one head, it simply means that out of all the cases, we are considering only that case when we have only one head. So we have only two cases when we have one head. But at least one head simply means that we need to have one head, but it can also be more than one head. So the event E is equal to head, tail, and tail head. But event F is equal to head, 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 tail, tail, head. Complementary event. For every event A, there exists another event not A. It is generated by A dash. In other words, we can say that if we have any event A, then there also exists a not of event A. Now let's consider an example. So if A is an event that is equal to two heads, which is head and head, then A dash is not two head, which is basically all the other events that is equal to head tail, tail head, tail tail. In other words, we can say that if we are considering A as an event that has two heads, then A dash will be an event that has less than two heads or no heads, which is basically all the other three cases. The event A or B. Let us consider two sets A and B, then event A or B is denoted by A union B. So basically, event A or B simply means that you consider all the elements that belong to either A or B or both. So A union B is equal to X says that X belongs to A or X belongs to B. So if we have any element that belongs to A union B, which simply means that either the element will belong to A or the element will belong to B, not necessarily both A and B. Even A and B. Let us consider two sets A and B, then even A and B is denoted by A intersection B. It means it contains all elements which are in both A and B. So A intersection B is equal to X such that X belongs to A and X belongs to B. In other words, we can say that the event A and B is the event which belongs to both the two events A and B. Or we can also say that if we have A intersection B, then all the elements of A intersection B will belong to both A as well as B. Mutually exclusive event. Let us consider two events A and B, then event A intersection B is equal to phi. It simply means that two sets A and B are mutually exclusive if there is no common element for both the two sets. Then it's called mutually exclusive event.